In this video, I'm going to do question 10 from Edexcel, A-Level Maths, Pure Maths, Paper 1 of June 2018. Okay, so here we go. First of all, let's see who I am. My name is Sunil Tanna. I'm a tutor and an author. My details are on the card. I'm available for one-to-one tuition, either online or if you live locally. I live in Buckinghamshire, England. I can also do in-person tuitions. So let's have a look at the question. Right, the question says, the height above ground, h meters, of a passenger on a roller coaster can be modelled by the following differential equation, where t is the time in seconds from the start of the ride. Given the passenger is 5 meters above the ground at the start of the ride, show that h is equal to this formula. So the question is, how do we solve this differential equation and make h the subject of the formula? Now, we use a technique here called separation of variables, where we bring all the h variables to one side and all the variables not involving h, t, to the other side. So if you look at this equation, we can divide both sides by h. So the left-hand side will become dHd over h, and multiply by dt. So what we will end up with 1/40th, because it's divided by 40, of cos 0.25 t dt, and that's allowed provided we integrate both sides. So I'm going to integrate the left-hand side, and I'm also going to integrate the right-hand side. Now the antiderivative of h, or 1 over h in this case, is natural log h. So natural log h, here we have 1/40th. Now we have to be a little bit careful about this. Sine is the integral of cos, so it's going to be sine of 0.25t. But if we were to differentiate 0.25t inside a sine, there would be a 0.25 outside. So to sort of reverse the effect, we also have to put a 4 in this. So if we differentiate 4 sine 0.25t, we would end up with a cos of 0.25t. And also, since it's an indefinite integral, we have to put plus c. Now we can simplify this slightly, where we'll have natural log h. 1/40th times 4 is 1/10, or 0.1. Sine of 0.25t plus c. Now to remove the natural log, we raise to the power e, which gives us e is equal to e to the power of all this. I'm going to write the e to the power c plus, I'll write it this way around, 0.1 sine 0.25t. Now, an important point here is when we add indexes together, that's the same as multiplying using our laws of indices. So this is the same as saying h is equal to e to the c times e to the power of 0.1 sine 0.25t. Now, we're almost there. We just have to get this constant in front, because this is an unknown constant. We don't know what the value of c is. However, we do know this condition. It tells us that the ride starts at 5 meters above the ground. So when t is 0, h is equal to 5. So when t equals 0, 5 is h is equal to e to the c times e to the 0.1 sine of 0.25 times 0, or sine of 0. Of course, sine of 0 is just 0, and so this will be e to the 1. So this tells us that e to the c is equal to 5. Therefore, we have our final equation, h is equal to 5 times e to the 0.1 sine 0.25t. And we've completed part A of the question. Now we're going to look at part B. I've got it on a new sheet so that we don't have to flip the page. Part B, show the maximum height of the passengers above the ground. Well, we already had an equation here for the height at any point in the roller coaster's trajectory. Now the thing we need to be careful about is when people see maximum or minimum, they immediately think of differentiation, but we don't need to do any of that. We just have to realize that sine in this case sine of 0.25t, can only vary between -1 and +1. So for part B, the maximum height is when sine of 0.25t is equal to +1. So that gives us the maximum height is 5 times e to the 0.1 times 1, or 5 times e to the 0.1, and we can type that in our calculator and it gives 5.3 meters. We're now ready for part C. The passenger reaches the maximum height for the second time, capital T seconds after the start of the ride. So if again we're thinking about the variation of sine of 0.25t. Now any sine curve, a sinusoidal curve, over its period will look like that. The first period will be here, and then we'd have a second period and a third period and so on. So the first period would be here, the first maximum would be here at 90 degrees, or pi over 2. The second maximum will be when the parameter for sine is 5 pi over 2, 360 degrees, or 2 pi radians after the first point. If you're wondering why we're working in radians, whenever we're doing calculus, unless it explicitly says we should be working in degrees, we should always be using radians. Okay, so what we know here is the second maximum height will be when 0.25 capital T, in this case, is equal to 5 pi over 2. So all we need to do is times by 4 to get rid of the 0.25, which gives us 20 pi over 2, or 10 pi, and putting that into a calculator, it gives us 31.4 seconds. And that's the end of question